All right, here is another key problem, I think, that's a review from pre-calculus. And the context that if you did take pre-calculus, which you probably did, that this material was presented in probably didn't, they may not have taken the time to relate it to calculus. And I'm going to do the same thing here. I'm just going to show you how to do the problem and how to come up with these three solutions for parts A, B, and C. Um, But we will return to this because this expression right here in part C is very key, to a fundamental concept, which we're going to call a derivative, and we're going to tie together something called a limit, which you probably worked a little bit with, ultimately to define the derivative. Okay, so this expression right here is going to be key for that. All right, so they're giving you a little bit of practice on how to go through the minutia or the mechanics of coming up with an expression here for a particular function. In this case, this f, 5x squared minus 8x plus 8. Now, what I did over here to kind of illustrate the main concept, when you first use this function notation, what you would have been doing is just maybe putting numbers in here. So, in other words, I would find f of 5, okay? And I would put a 5 in here for x, place the x with a 5, and that means all the other x's over here I'm going to replace with 5. So I could put f of -2 in there, f of 1. As long as this expression is defined for whatever value I put in there, in this case, polynomials are defined for any real number. I could put any real number in here for x and simplify it and get a value that corresponds with that. Okay, so that would make up the unique ordered pair for that particular x. So if I put in here a 2, I simplify all this over here, and whatever it simplifies to, what would that be? 5 times 4, which would be 20, minus 2, which would be 18, and another 8 would be 26. So, that would be like the 0.226. Okay. And, but here we're going to actually put an expression in there, x plus h. And so all I need to do is just, again, in the parentheses, put an x plus h. Now, in this case here, I don't believe my math lab will take it. You might want to try, but you might be able to substitute this in here to get the solution. But that would not be all that useful here because what we're going to have to do is use that expression down here, what we did in part A, to construct part B. So I'm going to try to simplify this. And the big mistake a lot of people will make here is they forget the order of operations. They'll want to distribute the 5 through here first. And that is not the case because this exponent governs this expression. So we want to expand that first, okay? And so what we'll end up with here is this idea of using FOIL. And I didn't write out all the work here, but if I have two of these expressions multiplied together, I mean, there's only so much I could review here. I'm going to assume you know how to do that. I'm going to take the first terms, x times x, then I take the outside terms and I get x times h, and then the inside x times h. So I'll get two of those x plus 8 or x times h's, and then the last term h times h. So again, I'm multiplying two of these factors together using FOIL. I end up with this. Now this I can distribute, so I get a negative 8x and a minus 8h, and then obviously here I just bring down the 8. Now I'll distribute through the 5, and I multiply all these coefficients by 5, and I end up with the following here. And then I am going to try to combine like terms, which I don't have any here, so I just need to leave it like this. All right, so now what I'm going to do is I am going to take this expression here. I want to take f of x plus h. I already found it right here. I'm just going to put it right here. Okay. And then I'm going to subtract f of x, which is up here. Now, another key place where people make mistakes is they don't put parentheses around here because since I'm subtracting f of x, that means I have to subtract the whole expression, which means I have to distribute through a -1, okay, when I do that. So this I'm just going to leave like this, and I did make a mistake. You can see some erasure marks here. I forgot to write the 5 plus 5h squared down on this next step, so I just tagged it on the end. But where these three terms are coming from here is the negative 1 times negative 5, I get negative 5x squared. Negative 1 times this, I get plus 8x. Negative 5x squared times 8. Or I'm sorry, negative 1 times 8. I'm going, let me try that again. Negative 1 times negative, or positive 5x squared, I get negative 5x squared. Negative 1 times 8x, I get 8x. And a negative 1 times positive 8, I get negative 8. Now I have some like terms I can combine, and so the 8s, they kind of add up here to 0. They do add up to 0. Same thing with the 5x squareds, they add up to 0. And also the negative 8x and plus 8x. And you'll see these patterns here. So these things kind of cancel out, and that just leaves me with a 10x squared, a minus 8h, and a 5h squared, okay, which is what I leave right here, okay? So now, all I need to do for part C, since I found this, I'm just going to replace this in the numerator and just divide it by h. And that's exactly what I do here. So I found this up here. I'm going to take this right here and replace it with what I simplified it to. And then I still have h here. And then I'm going to simplify it. Okay, and this, like I said, is going to be the key step later on when we define this derivative. But right now, we're just going to simplify the expression. Notice I have a common factor of h in all of these terms, all right? And I think this scanned off here. There should be an h here, so I apologize for that. Looks like it cut off my parenthesis. I didn't realize that when I scanned it, so sorry about that. But I just take this expression right here. All these have a common factor of h. So when I factor out the h, I leave behind a 10x, I leave behind a negative 8, and I leave behind a 5h. Okay, so again, there should be an h right here. All right, and a close parenthesis, it just fell off the sheet here. Well, those h's cancel out, and that leaves me with a 10x, a negative 8, and again, like I said, should be a 5h written right there, and that's what we end up with. Okay. Now this is written in a little different format here. That is not an issue. That should not be an issue in my math lab. Whether I wrote these in different order. I just happened, like I said, probably because I forgot the 5h squared here when I first did that problem, as you can see by my erase marks. Okay, so there you go. That's this particular one. Like I said, this expression right here is going to be key for later on when we define something called the derivative. Okay, so that wraps up this video. And remember, always use pause and scroll to go back and forth if something's unclear to you until you get it. And try to make these as short as I can. I've been told I have a tendency to ramble, so I'll try to shut up right now and move on to the next video. All right.